Hi guys, today we're going to be talking about the intercept form for a quadratic equation. This is also known as the factored form. And you'll see why in just a minute. What this form looks like is y equals a times x minus r1 times x minus r2. It's called factored form obviously because it's basically just the factored form for our quadratic. And then a, as we talked about in class, is like some stretch factor. So we're going to start with looking at some different graphs of quadratics in factored form and see if we can pick out some key features. So we're going to do that with Desmos. Hopefully internet is working. There it goes. All right, so our first one is just going to be y equals, and then the quantity x plus 3 and x minus 1. Okay. It's our parabola. It's an open-facing parabola. The vertex is a minimum, and then we have a y-intercept, and we have two x-intercepts. Our goal here is to identify key features just from the equation. So if we're given x plus 3 and x minus 1, what would that tell us about the graph? Well, if I'm kind of hovering over these points, negative 3 and 1, I'm noticing, would be the solutions to this quadratic if it were equal to 0. And so we talked in class today about how x-intercepts are also called zeros, and that's because it's the values of x that would produce 0 as an output. So when you're given a quadratic in factored form, what it will essentially tell you are the x-intercepts. Okay, so you can solve each factor for 0. X plus 3 equals 0, and you get negative 3. And then x plus 1, x minus 1 equals 0, and you get an x-intercept of 1. So, so the formatting there is y equals x minus, should we say, I don't know, x minus a and x minus b. A and b would be your intercepts. Okay, so I'm going to turn this one off for a second. If a and b are both 1, we have one x-intercept. Let's try messing this around. Ooh, there it goes. So we're sliding down. And so if a is 6, we have x-intercept at 6. And then if b is 1, we have an x-intercept at 1. Let's try moving b. So b would be moving that second vertex, or second x-intercept, sorry. And it would just be whatever that b value is the x-intercept. A is changing where the first x-intercept is. Okay, so we are going to, from here, be filling out a notes page to help identify what would our key features be. Okay, so I'm going to slide this, and we're still in this row for intercept form. What we can say about this intercept form or factored form is that under miscellaneous, it's going to give the concavity. And so what I mean by that is if the a value is greater than 1 or greater than 0, it's an open up parabola. And if a is less than 0, it's an open down parabola. Okay, it's also going to give the real roots. Okay, so the real roots are the x-intercepts. And so those would be our values of r1, 0, and r2, 0. And that comes from, in our form, r1 and r2 would be the solutions to each one of those factors. Okay, axis of symmetry. Let's go back for a second. And let's see what's going on here. I'm going to make these a little bit nicer values, maybe 3 and negative 1. And let's identify where the axis of symmetry falls. In this case, the axis of symmetry is at x equals 1. And how can we, just from the values of 3 and -1, how can we find this x value? How can we find 1? It's going to be exactly halfway in between the two x-intercepts. Okay, so really what we can do is find the average of the two x-intercepts, and that would tell us right in the middle where our x-intercept falls. So let's try showing that. X would be a quantity, a plus b, and we divide that by 2. So what we're doing is finding the average of a and b. And as I move a, notice that the axis of symmetry is going to move. And then as I move b, the axis of symmetry will move. So our axis of symmetry can be found by taking the average of the two roots. So r1 plus r2 and divide by 2. Okay, the vertex. The vertex is the ordered pair. And since we know the axis of symmetry, we know the x-coordinate for our vertex. So we can do substitute the axis of symmetry value into the equation to find the y value. Okay, so as an ordered pair, what that would look like is the x-coordinate is just going to be the same as the value for the axis of symmetry, r1 plus r2 divided by 2. And then to find the y, we want to take whatever number we get here and like plug it into the equation. So I'm going to use function notation here. And what this means is we're going to evaluate the function at this value, r1 plus r2 divided by 2. Okay. Lastly, we're going to talk about how to graph. So if you're given an equation in factored form, how do you graph? You would start with plotting your x-intercepts. So perhaps you have x-intercepts here and here, and I'm just doing it generically with no scale, right? Because it really doesn't matter what your x-intercepts are. From there, you want to find and plot your vertex. Okay. So how do you find your vertex? First, you want to find the axis of symmetry. And the reason that's helpful is because you know the vertex falls along that line. And once you find that x value, you can plug it into the equation to find the corresponding y value. And perhaps you find your vertex is up here. And just like with a line, how you need 2 points to draw a line, with a parabola you need 3. So you would use the x-intercepts and that vertex to make a sketch of your graph. Okay, let's take a look at an example of graphing. We're going to be graphing the equation y equals -2 x plus 7 and x plus 3. All right. What we're going to do is find the intercepts first. So the intercepts are the solutions to your factors. So the x-intercepts in this case are -7, 0, and -3, 0. You can plot those on our graph. Okay. We could also, I didn't put it on our list, but we could also find the y-intercept, right? So the y-intercept is when x is 0. So if we put a x value of 0 in, we would get negative 2 times 0 plus 7 times 0 plus 3. That would be 21 times 2, negative 42. So 0 and negative 42 is our y-intercept. What that tells me is it's going to be way down here, and I'm already getting a picture of this graph. It's going to be pretty sharp. It's going to come up, curve, and then come back down again. Okay, let's try and find the vertex next. The vertex is going to be halfway between these two intercepts, so I want to find the average of the two intercepts. X equals negative 7 plus negative 3 divided by 2. And we find that x equals negative 5. So you don't need to plot this, but what you've just found is the axis of symmetry is at negative 5. Your vertex is going to fall somewhere along this line. So what we need to do is find that ordered pair. I know that it's going to be negative 5 comma something. To find that y, we substitute negative 5 in for x. So y equals negative 2 times negative 5 plus 7 times negative 5 plus 3. Simplifying here, we get negative 2 times 2 times negative 2. Let's see, negative 2 times 2 is negative 4, and then negative 4 times negative 2 is a positive 8. So y equals 8. So we know that our vertex is the ordered pair negative 5 comma 8. We really just need, our 3 points to make our parabola, but let's use that a value as well. We talked in class about what that a value would do to a graph. The negative is doing the reflection component, so it's making it a downward facing parabola and making our vertex a maximum. And then the 2 is stretching our graph. So the 2 is making our graph skinnier. Traditionally, you go like right 1, up 1 to find like your next point on just a regular x squared. But because we have negative 2 as our a value, we're going to go right 1 and then down 2. So we're making that vertical change, multiplied it by negative 2. Traditionally, we go right 2 up 4, because 2 squared is 4. But we would be taking the y value and multiplying by negative 2. So we're going to instead go right 2 and then down 8. Notice that will give us our x-intercept. By symmetry, we have a point on the other side of left 1 down 2, and then left 2 down 8. So we have a few additional points for this one that we can plot. So we have a downward facing parabola. It's a little bit skinnier because of that stretch factor, and we could use the x-intercepts to find our plot. Let's do one more. Y equals 1/2 times x plus 5 times x minus 1. So this is our factored form. We're going to start with plotting our x-intercepts. So our x-intercepts are the zeros or the roots of these factors. So that would be negative 5 and 1. From here, we can find the axis of symmetry. The axis of symmetry is going to be halfway between these two x values. So I'm going to find the average by adding them together and dividing by 2. This is negative 4 over 2, which is negative 2. And so our axis of symmetry lies along x equals negative 2. And then to find the vertex, we're going to plug in negative 2 into this equation. So y equals 1/2 times negative 2 plus 5, negative 2 minus 1. That is 1/2 times 3 times negative 3. Negative 9 times 1/2 is negative 4.5. So our vertex is the ordered pair -2, comma, -4.5. Let's use our stretch factor to find a few additional points on our graph. What that stretch factor tells me is if I go right by 1, how much I'm going up. Okay, so here's kind of the pattern that I'm using with that a value. On a parabola, if you're at the vertex, when you go right 1, you go up by that value of a. Okay, and that's because originally it was 1, but you're taking 1 times a. If you go right by 2, you would be going up 4a. And that's because originally it would be going up by 4, but you're multiplying that y stretch by a. You'd be going right 3, then you'd be going up 9a, and so forth. So for our problem, we're going to go right 1, and then we're going to go up 1/2. So right 1 and then up 1/2 gets us to the order pair -1, -4. By symmetry, I can find the other point. What happens if I go right 2? Well, right 2, I usually go up 4, but I'm only going to go up half that height because our stretch factor is 1/2. So right 2 and then up 2. 1, 2. By symmetry, I've got the other point right there. And then if I go right 3, I usually go up 9. I'm actually going to go up 9/2, which is 4.5. And that's where we're getting our x-intercepts. All right, so there's our second example. Thank you.